Hey everyone, welcome to Code Harmony. Today we are going to solve LeetCode problem number 862. Shortest subarray with sum at least k. And this question has been asked recently by Meta couple of times in their technical interviews. Okay, let's have a look on the problem statement. Here we will be given an array nums and an integer k. Okay, they are saying that we are given nums array and an integer k, and we have to return the length of the shortest non-empty subarray. Shortest non-empty subarray of nums with a sum at least k. And if there is no subarray, return -1. I hope you already know about the subarrays. It's a contiguous part of the array, a slice of the array. Okay, so we are given an integer array nums and a value of k, and we have to cut a slice from that array such that the sum of the slice is greater than or equal to k, and we have to minimize the length of that slice. Let's also have a look on the constraints. In the constraints, they are saying that the value of k will go from 1 to 10 to the power 9. It means the k will always be positive, but the numbers can contain negative values, and the length of the array is going till 10 to the power 5. So here this is the catch which is making this problem hard, because this problem is pretty similar to this problem, minimum size subarray sum. Or you can assume that this is a prerequisite before solving this problem. First of all, let's try to understand what is this problem, minimum size subarray sum. In this problem also we will be given a value of array which is called sum and a value, integer value. Here this is called target. And we have to find the subarray of minimum length whose cumulative sum is greater than or equal to target. Okay, the problem statement is pretty same, that we are given an integer array. In this case, all the elements are positive, and in our question we might have negative values as well. So if we do not have negative values, it's pretty straightforward. We can use a variable sliding window to solve that question. Let's quickly have a look on the variable sliding window approach to solve this kind of problem, where we have all the positive elements and a target, such that we have to find subarray whose sum is greater than or equal to target, and we have to minimize the length of that subarray. So first of all, if I start with 2 is a subarray but length is not matching, 2, 3, which is 5, which is not matching with the target value. If I include 1, the total length is 3 and the sum is 6. 6 is also not passing target value. If I include 2 as well, the total sum will become 8, and 8 is greater than or equal to 7. It means this is a valid window. So in my answer I can update the value 4. Now as we have reached a subarray which is having a valid sum, now I will try to reduce the subarray so that we can find the optimal minimum subarray length. If I try to discard this element from the left, the sum will become 6. It means it will invalidating the range. So what I will do is I will try to add another element. Another element is 4. If 4 is added to 6, it will become 10. 10 is also greater than or equal to 7. Okay, so I can capture this as well, and this length is 4. So I don't have the need to capture it in my answer variable. Now I will try to reduce it from the left. 3 is the element which I have discarded, and now the sum will become 10 minus 3, which is 7. 7 is greater than or equal to 7. So this length is also acceptable. Okay, and now I will capture my answer as well. Now my answer is 3. If I further discard 1, it will be 6. Now 6 is not a valid answer, and then I have to add another element. 2, 4, 3. 2, 4, 3, 6 and 3, 9. 9 is valid. 9 is greater than or equal to 7. 3 is already captured. I don't have to capture. Now if I try to remove the 2 from the left, I will be left with 4 and 3. 4 and 3, the sum is 7 and which is greater than equal to 7 and the length is 2. 2 is better than our previously captured answer, so I will capture 2 in the answer, and ultimately answer will be having the length of the minimum subarray whose sum is greater than equal to the target. This approach was working here, and this approach is called variable sliding window, where I'm fixing the range, or you can say I'm taking 2 pointers, left and right, and I'm incrementing the right until I get the value, desired value. And if I have got the desired value, then I will try to go greedy and I will try to reduce or increment the left pointer so that I can get further minimum subarray length. Firstly, I incremented right, and in a valid range I will incrementing left. Okay, so this was working because all the elements were positive. Now how can I say that this approach is not going to work on this problem statement? Because first of all, in this problem statement we have negative values as well. Let's say this is my nums array and this is the value of k. If I use the similar approach, I am considering this as my sliding window, and in the answer variable I will capture my length of the subarray whose sum is greater than equal to 4. 2 is the subarray, the sum is not greater than equal to 4, so I will just ignore it. For this range, the total sum is 1. Now for this range, the total sum is 3. This is also not greater than equal to 4. And now to this, it will be 5. 5 is greater than equal to 4. It means we have found a valid subarray, and the answer is going to be, answer can have 5 in it. Now I will try to go greedy and I will try to reduce the range. This is the right pointer, this is the left pointer. I will try to reduce it from the left till it remain valid. If I remove the 2 from the left, the cumulative sum, the current sum of this range will be 3. So now as it has become 3 is not greater than equal to 4, I will not further reduce it as per my current approach. But if you have a look, this is having a valid answer, because I did not remove -1 in this case. If I would have removed -1, I would have got my answer, which is 4, and here the length is 2. But now in this case, the length will remain 5. Sorry, not 5. Answer is going to have length, not the value of sum. So the answer was 4 initially, left to right, and now it is 3. Answer cannot have 3 because for this range the total sum is 3, which is not exceeding value of k. Okay, so this is why the variable sliding window approach is not going to work here, because 2, -1, 1, 3, the whole range is valid. Firstly I have kept increasing the value, and now when it is the time to decrease the value, I will be able to decrease till this point, because this range is having sum equal to 3, which is not surpassing 4. Okay, so now if I say the variable sliding window approach is not going to work here, what will work here then? So here the approach that is going to work here is, we need to keep track of the prefix sums. Let me try to explain that approach to you. First of all, I will keep on incrementing my window. Now if my window is having current sum greater than equal to k, this is the time when we have to decrement the value. When you are decrementing the value, you will try to remove a piece from the starting. Let's say you are removing a piece, you are removing this piece, and what is this piece? This piece should be of the minimum sum. because as we have positive as well as negative integers, so let's say 2 is a subarray of size 1, but 2 comma minus 1 is a subarray of size 2, but the cumulative sum of 2 is 2 and the total sum of this subarray is 1. So if I have to cut a piece, I won't cut a piece of size 1, I will cut a piece of size 2. Okay, you got the idea? So this is why I will cut a piece considering in my mind that I have to cut a piece of minimum sum. And my current range is from index 0 to I. So this is my current range till R. And if I have to cut a piece, I will definitely cut a piece from the starting. From the starting I mean from the index 0. If I have to cut something from index 0 to, let's say, index j, what is this? This is a prefix sum of index j. So till this moment, I have to keep track of the minimum prefix sums, or you can say all the prefix sums and in the minimum order. And to use that, what I can do? What data structure I can use? Can I use queue? Every time I have to, let's say when I am at index I, what I have to know? I just have to know the minimum prefix sum so far. I am not bothered about the other prefix sum. So in that case, I am going to use heap data structure. So using min heap data structure, I will try to get the minimum prefix sum. Okay. And the minimum prefix sum, if I get the minimum prefix sum, I will also try to see the value of j. At what value I got this minimum prefix sum. So once I have this value, this j value and this I value I already have, I can know whether this range is valid or not. Current sum till this moment, prefix sum till this moment. If I decrement prefix sum from current sum, I will have this range. If this range is greater than or equal to k, I will include this length in my answer. Otherwise, I will discard it. If you have any doubt in this approach, you can comment down below. Okay, let me try to run on this example case. So now I have decided that I will be taking a heap data structure where I will be capturing the prefix sum and index till that value. So first of all, I will try to increment my current range. I am incrementing my current range. Current range is 2. And with the increment with the increment of this current range, I will keep on capturing the prefix sum values in a heap, or you can say this is the heap data structure, or you can say priority queue. That is the same thing. My current sum is 0. I will capture the current sum and let me say index is 0. I will be iterating over the indices. And let's also say this is the answer. Answer is plus infinity in the starting, and I will keep on capturing the minimum value. Current sum is 2. After one iteration, current sum is 2, and the current index is already 0. Current sum is 2. 2 is not greater than or equal to 4. It means this is not a valid subarray. And now it's time to offer the value in the priority queue. In the priority queue, I will add the current sum, and this current sum is at index 0. This is not the current sum, actually this is the prefix sum. So this prefix sum is always starting from index 0. This is going to be the slice. These are the slices which I am going to remove from my current sum to make a valid window. Okay, so this is the value. Now if I try to move further and I try to increment my range, I have encountered -1. If I add -1 to my current sum will become 1. 1 is also not surpassing k, so it is not a valid window. But I can capture the prefix sum. Prefix sum is 1 here, and 1 is at index 1. So 1 will come before this value because the 1 value is lesser than 2. Okay. And now I will try to further increment my value of this window. Now the current sum has become 2 again. It's 2 again, and the value of the index is 2. So it will be 2 and 2. Okay. But it is not valid. If I include 3 in this case, it will become 5. So 5 is valid one. 5 is valid one, and now 5 can also be my answer, because this 5 is coming from 0 to 5. 5 can also be my answer. And now I will try to reduce my window. So how can I reduce the window? Now just by removing the slices from the starting. So what is the least amount of slice we have in the starting? That is of prefix sum 1, which is this one. So first of all, I will try to remove this window from this slice from my window. Okay. Now this sum is 1. So if I remove 1 from it, 5 minus 1, which is 4. 4 is also a valid window sum. Okay, the 4 is acceptable. And in this case, what is going to be the range? What is going to be the window length? Window length is going to be my current index minus the index of this prefix sum, I minus j, which is, what is the value of that here? Current index was, I was not incrementing the current index. So the current index at this 3 is 3. And from here is 1. So 3 minus 1, which is 2. So 2 is going to be my answer. And now after this window, my array is completed, and now the best answer I have captured so far is 2, which was not the case when I was writing the variable sliding window. Okay, so the main intuition behind this problem is that, first of all, I have to keep on incrementing my current range, or you can say R with index I. Now if the current sum is greater than equal to k, if current sum is greater than equal to k, then we need to reduce slices, or you can say prefix sum from the starting. Let's say we have two prefix sums. Let's say this array and this array. And this array is giving prefix sum 2 and this array is giving prefix sum 1. So I will reduce one prefix sum. And this I will take from my heap. I will maintain a pair always. What is prefix sum value and the index. So this I will try to remove from my range, and this index is 1. So current index is I minus index. So this is going to be my window. Okay, I hope you clear on this approach. And here for this approach, if you try to have a look on the time and space complexities, what is going to be that? Time complexity is going to be, I'm iterating over every element, and every element I am also using a PriorityQueue data structure, or you can say heap. And insertion in heap or retrieval in heap is going to be log n operation. So in total, the time complexity is going to be n of log n. And what is the space complexity? Space complexity is going to be on for additional heap data structure. So this is our optimal approach. And now try to write a code for this approach. Firstly, let's take a couple of variables int n equal to nums.length and our answer, initializing it with the maximum value of integer, and the current sum will be our sum throughout the loop for int I equal to 0, I less than n, I plus plus. And in the end, I have to return my answer. Okay, now template is ready. And first of all, my current sum will be incremented, current sum plus equal to nums.i. And now I'm initializing my window from left to right, from index 0 till ith index, till 0 to ith index. If that window itself is having a sum greater than equal to k, that is a valid window. If current sum is greater than equal to k, it means that window is itself a valid window. Answer equal to math.min current answer if we have captured any answer so far. Otherwise, from 0 to ith value, if I value is 2, 0, 1, 2, which is of 3 size, so I will keep it I plus 1. Okay, now I have captured the window from index 0 to index I. Now from index 0 to any index j, there might be some prefix subarray, which if I have to remove from this window, I will get the sum greater than equal to k. It means I need to see what prefix I can remove, and for those prefix sums I was capturing priority queue. Priority queue, that is our heap. Let me take integer for now. Integer array. First element is going to be the prefix sum and second element is index at which the prefix sum is ending. Priority queue is equal to new priority queue, and I'm initializing that window. Let's write lambda here for that. A hyphen b return a0 minus b0 directly. Okay, I hope that is going to work. Now priority queue is ready, and now I will only see if there is an element in priority queue. Priority queue is not empty. If priority queue is not empty, and if I remove the first element from the priority queue from my window, and even after removing that, the sum value is greater than equal to k, it means I am able to reduce my window. So the current sum minus prefix sum greater than equal to k. And what is the prefix sum? My priority queue dot peak, and from that peak I am getting the 0th value. 0th value is the sum. If that value is greater than equal to k, it means I can let's extract it. Piece equal to priority queue dot poll, and from that piece, let's say that index is j. From I to j I have another window. That another window I am going to capture math.min. What is that window? I minus piece at index I. Index I is going to store that window. And after all the operations, the current sum is also a prefix sum that I am going to add in my priority queue. Priority queue, I will offer in the priority queue new integer array where we have current sum and the current index, semicolon. Let me try to submit over sample test cases. I forgot to mention and. Traffic is too much on this question today. Okay, these two answers are failing. I mentioned the min value, it should be max value. I'm very sleepy right now. Okay, these three sample test cases are passed. I also submitted this approach, but I got wrong answer on this approach because it might be because of some overflow, because here I am capturing current sum, and the current sum is being stored in the priority queue in the integer form. Instead of integer, I should take long here. Let's try to submit this problem and see how many test cases are passed. Do we have any other test cases apart from this? This is the only test case which is failing, and now I need to change from this integer array to long value and integer value. Long value for sum, integer value for index. It means I have to take another class. Now this test case is also passed. What I did is, instead of taking integer values, I created my own object class where in the value I am considering, you can consider it as a pair, where I am capturing long value of prefix sum and index. Instead of that, I also converted the current sum to long. So these changes will avoid the overflow in my approach. And now I also made the change here, long.compare these values, compare the prefix sum of these values, and here I am capturing it in the value item and using the constructor of the value class to offer it in the priority queue. Let's try to submit this problem. It got submitted successfully. Hope you understood the problem. Thank you guys. If anything is not clear to you, just try to watch that portion again, and still you face any issue, just write down on the comment section below. Okay guys, bye bye.